Hello everybody, welcome into another lesson. So today we are going to talk about systems of equations. So again, this may seem largely like a review from algebra, where we solve the systems of equations and figure out the point of intersection of these two lines. But not only are we going to do that, we're going to graph the two lines with their point of intersection. So here you have a given system of equations. X plus y equals 3 and x minus y equals 1. The goal of solving a system of equations is to figure out where do these two lines intersect. So there were some methods that we learned in Algebra 1 I should say. We learned elimination, which is going to be used in this one. We learned multiplication with elimination, which is a little bit more, and then we learned about substitution also. We're going to see all those at work today. So first things first, let's go ahead and solve this system of equations. Now, I think it's clear to see if you add these two equations together, you'll get rid of the y variable, and then you'll end up being able to just have the x and solve for x. If you add these together, you would get 2x, the y's go, and then 3 minus 1 is 2. So you would get 2x equals 2, which would give you then the x equals 1. And then in order to solve this, all you need to do is take this x equals 1, put it into any of these two equations, take your pick, and solve for y. So if I put in 1 in the first one, I would get 1 plus y equals 3, which would give me y equals 2. So my coordinate of the point of intersection of these two lines would be at the point 1, 2. So that's great. We know the point of intersection of these two lines to be 1, 2. Now, what if also I want to graph the line? Well, it's nice and easy for us because these are in general form, standard form, so all we need to do is find the x and y intercept. If we deal with the first line, x plus y equals 3, the x-intercept would definitely be at 3, so 3, 0 for that. And then the y-intercept would be at 3 also at 0, 3. So just plot those 2 points, and then you have also, you have x minus y equals negative 1. To find the x-intercepts at y equal to 0, you would end up getting that x equals negative 1 for the y-intercept. So the x-intercept would occur at negative 1, 0. And then to solve for the y-intercept, you would get negative y equals negative 1, which would give you y equals 1. So it'd be at 0, 1 for the y-intercept of that line. And then, once you've plotted all your points for your lines, plot your point for the point of intersection, which would be at 1, 2, which would be right there. Then you just draw your lines through them. So I'm first going to draw x plus y equals 3, which would cut right through there like so. And then I'm going to draw my line through x minus y equals negative 1. And I have graphed both of these lines, and I have their point of intersection here at the point 1, 2, where they both intersect. And I got 5 more examples here that we're going to do today, and that'll be it for the lesson. This shouldn't be a terribly long lesson, but still it's a very important one to be able to solve systems of equations. I don't utterly obliterate my coordinate plane. There we go. Alright, put one here, put one there, put a thing here. Perfect. Alright, it's reassembled. Then I can erase these equations. We'll do the next one. So let's see here. Let's say we got the next system to be 2x plus y equals 7. Then we have 3x plus y equals 9. So of course we're going to graph these two lines, and we're also going to label their point of intersection because they are going to intersect. So if you look at these two equations, the 2x plus y equals 7 and the 3x plus y equals 9, I think it's plain to see you could subtract the second equation from the first and get rid of the y variable, and then you'll be solving for x. So let's go ahead and do just that. If you subtract 2x minus 3x, that's negative x. Y minus y is 0. 7 minus 9 is negative 2. So you would get negative x equals negative 2, giving you an x-coordinate for the point of intersection of 2. Now, in order to solve for the y, stick this value of x into either equation, whichever one you choose. I'm going to stick it into the top one, so you'll take 2 times 2 plus y, set that equal to 7, which would give you y plus 4 equals 7, gives you the y-coordinate of the point of intersection of the two lines to be 3. So the point of intersection is going to be at the point 2, 3. That's where these two lines would intersect. Now we're also going to graph these lines. So if I were to, let's figure out the first one here, okay? So the first line I'll do in the purple marker. If I want to find the x-intercept, I set y equal to 0, right? So you would have 2x equals 7, which would give you x equals 7 halves. So the x-intercept would be at 7 halves 0, which is also 3 halves, 3.5 0. Now if I want to find the y-intercept, I'll set x equal to 0. I would just get y equals 7. So the y-intercept would be at 0, 7. Now that I've found both of my intercepts, why don't I plot them? So 7 halves 0, that's 3.5 0. That'd be right there. Now 0, 7, that's 3, 4, 5, 6, 7. That's all the way up here. So now I've plotted both of those points. Okay, now I need to solve for the other equation, the 3x plus y equals 9. If I want to find the the x-intercept, I'm simply going to set the y equal to 0. I would just get 3x equals 9, which would give me an x value of 3. So my x-intercept would be at 3, 0. Wow, they're cutting it awfully close. So the x-intercept is right there. And then you would have, if you want to find the y-intercept, set x equal to 0, you would get y equals 9 for the coordinate of your y-intercept to be 0, 9, which would go up here. And then you're going to plot the point of intersection, which I'll plot in red. That'll be at 2, 3, which will go right here. That's the point of intersection of these two lines. So now I'm going to go ahead, connect my two lines here. So there's going to be the first line. They're awfully close together, but they do intersect. So And there's the two lines graphed with their point of intersection at 2, 3, right over here at 2, 3. All right, 4 more problems. It's good to get the x and y intercepts of each line, plot those, and then plot the point of intersection, and then draw each of the lines through those. That's how you make a good connection. Alright, let's come up here. I destroyed a very good part of this coordinate plane. Alright, let's reassemble this. Alright, there we go. Reassembled coordinate plane. Let's see what the next equations hold for us. So we have x plus 2y equals 10. And then we're also given 3x minus 2y equals 6. So we got both of those lines, 3x minus 2y equals 6 and x plus 2y equals 10. First thing I would do, go ahead, solve the system of equations, and then figure out what is your point of intersection. Well, you have a plus 2y and a minus 2y, so if you add these two equations together, you can get rid of the y again. So add them together, x plus 3x, that would give you 4x. 2y minus 2y is 0, and then equals 10 plus 6 is 16. So you have 4x equals 16, which means x would equal 4. So the x coordinate of the point of intersection is at 4. Now, in order to solve this equation, to solve for y, put this x value into any of these two equations, and then you can solve for y. We'll put it into the top one, so if I put in 4 plus 2y equal to 10, I'll end up getting that 2y equals 6, which gives me the y coordinate of the point of intersection at 3. So my point of intersection for these two lines would be at the ordered pair 4, 3. So we found our point of intersection now to be 4, 3. Now let's go ahead and graph these lines also. I'll use the purple marker to denote the line x plus 2y equals 10. So if I want to solve for the x-intercept of x plus 2y equals 10, set y equal to 0, you'll get x equals 10 for your x-intercept at the point 10, 0. So let's go ahead and plot 10, 0. Right there, that's 10, 0, okay. And then if I would like to solve for the y-intercept, set x equal to 0, that would give me 2y equals 10, which means that y equals 5. So my y coordinate, my y-intercept would be at the point 0, 5. So we'll put 0, 5 on here. Let's plot 0, 5 right there. Okay, so I've plotted the points for this one. Now let's do 3x minus 2y equals 6. I'll do that in green. So let me write down here so that way I can clearly do stuff. If I want to find the x-intercept of 3x minus 2y equals 6, set y equal to 0, I'll end up getting 3x equals 6, which would give me x equals 2. So the coordinate of my x-intercept should be at 2, 0. So I'm going to plot 2, 0 right there. Now, if I want to find my y-intercept, set x equal to 0, I would end up getting negative 2y equals 6, which would give me y equals negative 3. So my y-intercept would be at 0, negative 3. So I can find that right there. So now I've plotted the x and y intercepts of both lines. Now let's plot the point of intersection in the red marker. At 4, 3 would be right there. That would be right there. Perfect. Now let me go ahead with the purple marker, connect the first line together. Pretty steep negative slope. That's roughly what they would look like. And then you take the green marker for the other line here, draw it through the point of intersection. And that's what this system of equations would look like graphed. You have both lines with their point of intersection at the point 4, 3. Now I got 3 more problems, then we'll be done. Alright, let me redraw this, get that redrawn, put that together. Alright, I think I've reassembled it. What's the next one? We have 3x plus 2y equals negative 30, and then you just have y equals x. So you have a system of equations here where you have 3x plus 2y equals negative 30, and then you have the line y equals x. Well, let's solve for the system first. Let's determine our point of intersection. Now, in this case, the method of elimination is not going to work out the best for us. We can use the method of substitution to solve this. So if you put in that x for where y is by substitution, you can start to solve for x. So take 3x plus 2x, since y equals x, set that equal to negative 30, which would give you 5x equals negative 30, and then x would equal negative 6. So there's the x-coordinate of your point of intersection. Now, what if then we want to solve for y? Just put the x value into any of these equations. I think it's obvious we want to go with the y equals x. You would also get y equals negative 6 if you did that. So your point of intersection would be negative 6, negative 6. So the point of intersection of these two lines is at the point negative 6, negative 6. Now, we found the point of intersection. What about graphing the two lines and their point of intersection? So let's start out with 3x plus 2y equals negative 30. To find the x-intercept, set y equal to 0, you would just get 3x equals negative 30, which then would give you that y is equal to negative 10. Not y, excuse me, I'm sorry. X is equal to negative 10, which would mean then the x-coordinate or the x-intercept would be at negative 10, 0. So let's plot the point negative 10, 0. 10 right there. There's negative 10, 0. Okay. Now, if I want to find the y-intercept of this, set x equal to 0, you would get 2y equals negative 30, which would give you y equals negative 15. So the coordinate of your y-intercept would be at 0, negative 15. So let's go ahead, plot 0, negative 15. 15 right there. Alright, so now I have plotted my x and y intercepts of 3x plus 2y equals negative 30. Now let's plot y equals x. Well, I think it's plain to see that 0, 0 is an excellent candidate, right? If y equals x, then you would also have the point 1, 1. So those are pretty easy points. So I've plotted those 2 points. Now let's label the point. Let's plot the point of intersection at negative 4, 5, 6. Right about there. So there is the point of intersection roughly. Now that we've plotted the x and y intercepts or other points, let's go ahead and draw these 2 lines. It'll cut right through there. So there's the line 3x plus 2y equals negative 30. Now let's plot y equals x. So there's both lines graphed with their point of intersection being at negative 6, negative 6. And I just have 2 more exercises. Lesson's a little longer than I thought because of the graphing component, but I'd still rather teach it right and get it right and show you the examples. Plus, this is a good review of how to solve systems of equations since we haven't really done this in a while. I know we did a little bit earlier in the course with different angle problems and stuff, but we really haven't done it well since Algebra 1. So, and with Algebra 2 right around the corner, I feel this is pretty important. Alright, there we go. So, next problem is 4x plus 5y equals negative 7. Oh, this is going to be a real fun one. And then you have 2x minus 3y equals 13. Alright, so here's a system of equations. You have 4x plus 5y equals negative 7. Then you have 2x minus 3y equals 13. Well, yeah, we're going to solve by method of elimination, but if we remember, we still want to find a variable to eliminate in this case, because if we try to do substitution, it's not going to be pretty. We're going to have a bunch of fractions, and no one wants to do that. So what I would suggest first is that we multiply that second equation by 2. So if we multiply that second equation by 2, you would end up then having 4x plus 5y equals negative 7, and then you would have 4x minus 6y equals 26. Now you can solve this and eliminate the x variable. So if you just subtract the second equation from the first one, you'll end up getting 4x minus 4x is 0. 5y minus 6y would actually give you positive 11y, would be equal to the negative 7 minus 26. Well, that's negative 33. So you end up getting 11y equals negative 33. giving you the y-coordinate of the point of intersection to be -3. So we found the y-coordinate of the point of intersection to be -3. Now let's go ahead and let's solve for x. All you have to do that is put this y value in to any of these two equations. I'll pick the top one. So I'll put in 4x plus 5 times -3 equals -7. Well, 4x plus, that'd be 4x minus 15 equals -7, which would just give you 4x equals 8, which gives you your x-coordinate of +2 for the point of intersection. So your point of intersection for these two lines will be the coordinate 2, -3. So at 2, -3, these two lines come together and intersect. Okay, now we've found our point of intersection. Let's find the x and y intercepts of these two lines. So the first one, 4x plus 5y equals 7, I'll do in purple again. To find the x-intercept, set y equal to 0, so you would get 4x equals -7, which would then of course give you x equals -7/4. So your x-intercept would be at -7/4, 0, which would be at -1 3/4, 0, which can be found right about there. Not a big fan of these fraction ones, as you can tell. And then you have to solve for the y-intercept, so set x equal to 0, you would get 5y equals -7, which would give you that y equals -7/5 for your y-intercept at 0, -7/5, which would be -1 2/5, which would be right about here. Yeah, I know it looks small to start with, but trust me, it's all going to come together. So I've plotted those 2 points. Now, I'm going to come down here in green marker. We're going to work on the second line, 2x minus 3y equals 13. So to find the x-intercept, set y equal to 0, you would get 2x equals 13, which would give you that x equals 13/2. So your x-intercept would be at 13/2, 0. So 13/2, well, that's 6.5. So let's find 6.5 right here. 6.5, 0. Now, of course, let's find the y-intercept, which would be -3y equals 13, which would give you that y equals -13/3. So your y-intercept would be at 0, -13/3. Well, what is -13/3? That's -4 1/3, which would be right about there. And then we plotted the x and y intercepts of both lines. Now let's plot the point of intersection, which would be at the point 2, -3, right there. All right, so now that we've labeled all those points, let's draw our lines. So here goes the first line, which is going to be 4x plus 5y equals -7. And then we'll plot the second line, which would be 2x minus 3y equals 13. So there's the two lines together with their point of intersection at 2, -3. And then I got one more problem, then we're done. I'm sure much to everyone's relief, we'll be done. Let's just rebuild this for one last exercise. Good Lord. All right. We have the two equations. 3x plus 2y equals 8. So we got 3x plus 2y equals 8. Then we have negative x plus 3y equals 12. So here is our next system of equations. I want to move that negative over because it looks like I'm subtracting. Alright, there we go. So this system, we have two lines, 3x plus 2y equals 8, and then negative x plus 3y equals 12. Well, this is going to be another one where we multiply one equation and then we eliminate. Then we either add or subtract them together. So, judging by this one, if you have a 3x and then a negative x, I would say multiply the second equation by 3, and then you can just add them together. So we'll still have 3x plus 2y equals 8, but we want to multiply the second equation by 3. If we do that, we'll get negative 3x plus 9y equals 36. Now I can add these together and eliminate. If I do that, 3x minus 3x is 0. 2y plus 9y, that's 11y. That would equal 8 plus 36, which is 44. So the y-coordinate of my point of intersection would be at 4. So y equals 4 for that. Now, to solve this for x, you're going to want to put this y value into any of these two equations. I'm actually going to do the second equation this time. I think it looks easier. So if I do that, I'll get negative x plus 3 times 4 equals 12, giving me negative x plus 12 equals 12. Well, x would just equal 0. So the coordinate for my point of intersection would be at 0, 4. So at the point 0, 4 is my point of intersection for these two particular lines. Great, I found the point of intersection. Now let's find the x and y intercepts of each line. If I want to find the first one in the purple marker, find the x-intercept, set y equal to 0, you would just get 3x equals 8, which would give you x equals 8/3. So the point, the x-coordinate, or the x-intercept would be at 8/3, 0, which is 2 2/3. So that can be found right there at 2 2/3, 0. Alright, now let's find the y-intercept, which can be done by putting the 0 in for x. You would just get that 2y equals 8, which would give you that y equals 4. So my y-intercept at this point would be at 0, 4. Okay, so now let's plot the point 0, 4. Okay, so now we need to use the green marker, the other color, to find the x and y intercepts of negative x plus 3y equals 12. If I want to find the x-intercept, I would just get negative x equals 12, which would give me that x equals negative 12. So then the coordinate of my x-intercept would be at negative 12, 0. So let's plot negative 12, 0. All the way over here. Now let's find the y-intercept. If I want to do that, I would get 3y equals 12, which would give me y equals 4. So my y-intercept would be at 0, 4. Well, what do you know? We have some overlap, and that's also where these two lines intersect. So let's go ahead here and draw our two lines. I know I'm not the straightest at drawing, but there's 3x plus 2y equals 8. Whoops, oh well, I picked the wrong color, but this other line here is negative x plus 3y equals 12. And you can see they both share the same y-intercept, and they intersect there at the point 0, 4. Yeah, so that's it for solving systems of equations and graphing them. Next lesson, there will be no graphing at all. It's going to make life a lot easier. We're going to write equations. We're going to learn point-slope form of an equation. And this is good for problems like, given the slope equals this and the line passes through this point. It's perfect to know that. Or find the equation of a line passing through these 2 points. So I hope to see everyone in the next lesson. Have a good night. Take care.